So we just saw in that nearpod activity that we can graph these functions by just making a table, picking some x's, find out what y is, plot those points, connect the line, right? That's what we did. In all of those problems, they were solved for y, right? It was y equals something else, or y equals 4x minus 3, y equals 5x minus 2, okay? So these steps to graphing here, we want to always make sure the y is by itself. We're going to make a table. The domain is that the x's or the y's? X's. If the x's aren't given, you pick your own. So that's what we saw in that second example. Okay. We plot those points and then we connect them. And that's all we're doing today. We just saw some examples of that. Yes, question. So let's look at what happens if y is not solved for y. Now we've been having, some of us had some trouble with solving for a variable. Remember, that's what we did on that last test. The last, almost the last 4 problems were solve for variable m or solve for variable x, and you had a lot of different variables. So like if I told you to graph this, you would first want to get y by itself or solve for y. And a lot of people, I saw this, they call it draw the river. So on the equal sign, you just draw a line. That way you know stuff has to go back and forth over this line when you move it. Okay, because some people have been like subtracting a number and then doing it from the same side of the equal sign. If you do it from one side of the equal sign, you have to do it the other. So I just wanted to put this here in case that helps you. But we want to review solving for y here. So I'm going to get this variable by itself. Okay, which means I need to move this 2x over to the other side. Just like if that was a positive 10, I would subtract 10 from both sides. Since it's a positive 2x, how do I move it to the other side of the equal sign? Subtract 2x, right? So I'm just going to take this and go subtract 2x. That becomes 0. And then I have to subtract 2x from this side of the equation. So I'm just left with y equals 4 minus 2x. So that one was pretty simple to get y by itself, right? If I would have told you to graph this problem and y wasn't by itself, you just get y by itself and then you start picking your points. Okay, I'm going to pick x's -1, 0, 1, and 2. Plug those in, find out what y equals, plot those points. How about this one? 4x plus 2y equals -6. I want to get y by itself. Now remember this 2, I'm going to undo that last. This is multiplication by 2. I need to undo that last, so I need to move this 4x over to the other side first. Just like in the last problem, how do I move that over the other side? Just like the last problem, since that's a positive 4x, I need to move it to the other side, so I will subtract 4x from both sides. I'm left with 2y over here. Why don't I just subtract these two right here? I can't. They're not like terms, right? This has an x, this doesn't, so I can't subtract. Okay. So I'm going to leave it as that, -6 minus 4x. And I'm actually going to move this up here so I have some more room to write. I'm going to move it right here. Okay. So I need to now get rid of this multiplication by 2. How do you undo multiplication by 2? Divide by 2. Divide this side by 2 so it becomes just 1y. And I divided everything on the left by 2, so I need to divide everything on the right by 2. You can do this one of two ways, whatever way you prefer. You can either write it all division by 2, or you can write the first term division by 2 and the second term division by 2. If you can divide both of these numbers by 2, go ahead and do it. If you can't, just leave it as all division by 2. But both -6 and -4 are divisible by 2, right? So I can go ahead and make this problem shorter and divide both of those by 2. Let's do this one first. -6 divided by 2, -3. -4 divided by 2, -2. I still have the x. There is my equation solved for y. Okay. Again, if I have that fraction over the whole thing or each term, it means the same thing. If this would have been like a 5, and this would have been maybe a 1, I probably would have just left it as all division by 2 instead of making them a decimal. Okay. But since both -6 and -4 were divisible by 2, I went ahead and divided them by 2. Does that make sense how that works? Questions on these two? Again, we're just solving these for y. If you had to graph them then, you'd make a table, you'd pick some x coordinates, plug them in, and you'd find out what y equals, just like what we did before. Let's look at two more. Here, I want to solve for y, so I'm trying to get this by itself. I undo the family member. Remember the people closest to him last. I'll undo this -3 last, so I need to move this x over to the other side. How can I move that x over?
Subtract x.
Yeah, subtract it, because it's a positive x, right? Subtracts x here, that goes away. Subtract x here. Why don't I make this 5x? You can't.
There's no variable.
They're not like terms. You can't. You just have to leave it as that. So again, you're still left with -3y on this side. You're left with 6 minus x on this side. Remember, you keep the sign that's in front of the number there. I need to get rid of this multiplication by -3 to get y by itself. Divide both sides by -3. Again, here I could either write it like that, or I could write it all divisible by 3. Those mean the same thing. Okay? If I divide each term by -3 or the whole thing by -3. Whatever way you want to do it's fine. Okay? Let's say I did it again, each term by -3. That cancels, so I'm just left with y. 6 divided by -3 is -2. Here, this is like a -1 in front of this x, right? We just don't write the 1. I have a -1 divided by -3. Well, those don't divide to give me an integer, right? So I'll just leave it at that. But I do know a negative divided by a negative makes it what? Positive. So I can just make that x over 3 now. So that would be my equation. If you wanted to leave it like this, at this step, well, it is over -3, but since I took this negative divided by negative, it makes a positive. Good question. Okay? But these are the same thing. Here I just went ahead and divided the 6 by -3, got -2. Here I took the -1 divided by -3 and made it a positive 1 over positive 3, because the negative divided by negative is a positive. Both of these, if you plug in x, you're going to get the same answer for y. Like if I was to plug in x is 3, let's just do that real quick. If I said, okay, x is 3, here's my t-chart. Let me clear out a space here. So I said, okay, here's my t-chart, x, y. When x is 3, tell me what y equals. So let's do this one first. If I plug in 3 here, 6 minus 3 is 3. And then 3 divided by -3 would be -1. Let's make sure I get the same answer here. If I plugged in 3 here, 3 divided by 3 is 1. -2 plus 1, -1. So these are the same thing. Either way, you'll get the same answer. Okay? Whatever way you prefer to graph. Questions there? All right, just a couple other things here. Sometimes, not on the homework today, but sometimes you see a function written like this. Remember the function notation? It says f of x is equal to 2x plus 4. F of x and y mean the same thing. Okay? So if you were asked to graph a function like this, you would still just plug in x's here. 2 times -2 would be -4. -4 plus 4 is 0. So then that means the function of x at -2 is 0. Plug in -1 here. 2 times -1 is -2. Plus 4 is +2, and so on. Then I would just plot these points. So if you ever see one of these on like some other standardized test or something that you take, this just means the function at x. It means the same thing as y. Okay? Just a different notation. So the ordered pair again would be -2, 0, -1, 2, and so on. You plug in 0, 2 times 0 is 0, plus 4 is 4. You'd graph these points and then connect them with a line. Now, who can tell me the difference between a linear graph and a nonlinear graph? What does that mean? Yeah, Tori.
Linear is like a straight line and a non-linear is one.
Exactly. A linear, okay, is a straight line. So we graph things when they're linear are things just like a straight line. Doesn't matter which way it goes. Okay, those are straight lines. Nonlinear graph is things that are not straight lines. Like things like, we call those parabolas, right? Or things like, things that look just not straight lines. Okay? These would all be nonlinear graphs. These would be linear graphs. Straight line is linear, red is nonlinear. Now sometimes you need to know, how can you tell if it's linear or if it's nonlinear before you even start graphing it? That way you know my answer is either going to be a straight line or my answer is going to be a curved line. There's 3 things you look for. Yeah.
This like the answers like if you had -2, -1, 0, 1, 2, like you would have same negative. You have negative answers on.
I just gave you a function and said, is this linear or not linear? You know that? Okay. Yeah. You know.
There's like an exponent.
Yes, that's one way. Let's go over those three ways. One way is if you have a variable in the denominator. If you have a variable in the denominator, you graph this, it's going to be some curved line. It's not going to be a linear. It's not going to be a straight line. That's one way. The other way we just mentioned, if you have any variables with an exponent, it's going to be a curved line, not a straight line. Okay? And the third way is if you have any variables multiplied by each other, like x times y, not a linear graph. If you see any of these three things in your function, you know it's not going to be a straight line. Otherwise, it probably is. Okay? Most of the ones, all the ones we're going to do today actually are linear, but you could graph nonlinear lines, right? It's the same thing. If I gave you this function, you would do the same thing. You could make a t-chart. Let's just say x and y, and let's just pick some points. Let's say if x is 0, what's y going to be? Well, 0 squared is 0. 0 minus 3 is -3. If x is 1, 1 squared is 1. 1 minus 3 is -2. And you do the same thing, and then you just plot these points. And then you connect them, but it's not going to be a straight line. In this case, it's going to be a graph that looks something like this. You would do the same thing here. You pick an x. What does y equal? Plot those points. But these are not linear graphs. These would be not straight lines. The one we're going to work with today are. But you could do nonlinear graphs by just looking at this and saying, is there any variables in the denominator? Is there any variables with exponents? Or is there any variables being multiplied together? These things would cause it to not be linear. Okay. So for example, look at this one. Think to yourself first. Before even doing anything, would this function be a straight line? Would it be linear? Or would it be nonlinear? Think to yourself a second. Give it a shot. You want to take a shot? Yes. Yes, this one would be linear. This one would be linear. There's no variables with exponents. There's no variables being multiplied. There's no variables in the denominator. Okay. The variables have to be multiplied by each other. Okay. This is multiplication, but they have to be multiplied by each other. How about this one? Linear or nonlinear? Nonlinear because exponents, you have a variable with an exponent, nonlinear. This will be a curved line. Okay, that's all we're talking about today.